Guys, this is the Integrated Science Unit 3. We are in the Chemistry Unit, Skill 3, Part 2. So we're still talking about phases of matter, and today we're going to talk about going between the different phases of matter. So remember, you have solids, liquids, and gas, and we're going to talk about the differences and how to change it. So first, this is a temperature versus energy input diagram. So you can think of this as a phase change diagram. And if we go over this, you'll see the lowest temperature would be down here, the highest would be up here. So if this line represents what temperature your substance is at. So as you put in energy. Now you could also go backwards and think of this as taking out energy, but so far we're just going to go forwards. So down here, this line, notice it's not flat. So the line going like that first one is going to be where it's at a solid. So whatever temperature range from A to B is, whatever this substance is going to be a solid. Then, as it heats up more, it becomes a liquid, and as it heats up more, it becomes a gas. But here's the interesting thing, and you probably saw this in your lab when you were boiling water, when you had water versus salt water and you boiled it and kept the temperature. Once it started boiling, it stayed the same temperature, okay? So these flat lines, even though you're putting in more energy, see energy input, even though you're putting in more energy, it stays the same temperature. So this is called the melting point, when you go from your solid to a liquid. So you're literally melting your solid. And as you melt a solid, it stays whatever that temperature is. So if you trace this over here, whatever this temperature is, that's that substance's melting point. As you go from a liquid to a gas, that's called the boiling point. And if you trace this over, whatever this temperature is, that is my boiling point. So there's a few things to know. First, melting point is also the same as the freezing point. So whatever temperature something melts at is the same temperature that something freezes at. So that's whenever a substance goes between a solid and a liquid, it always stays at that same temperature until the phase change is done. So whether you're putting energy in or taking energy out, your substance is going to stay that temperature during the phase change. While it changes from solid to liquid, it doesn't change temperature. Also, boiling point can also sometimes be called condensation point, just depending on which direction you're going. It can also be called vaporization point, but most people say boiling point. So that's when it's changing between a liquid and a gas. So a condensation is a gas going to a liquid. So you might see like condensation in the morning when you have some dew on grass or your windows, and that's because there was water in the air, and as it cooled overnight, it became liquid water. All right, so we're going to go over these changes all together. So first, going from a solid to a liquid is called melting, and that occurs when there's enough energy to overcome attractive forces keeping a substance together. So all of those molecules inside a substance are keeping them nice and tight, and then as you add energy, they start to escape from each other. The next thing is vaporization. This is going from a liquid to a gas. So it's also called evaporation sometimes. Vaporization is kind of more sciencey, evaporation is more standard English. So this occurs when liquid molecules get enough energy to overcome atmospheric pressure. If you think about this liquid, right on top of it is all this air, and the air is pushing down on the liquid. So you have to have enough energy in the liquid to escape up into the air. So that could change if you have like lower atmospheric pressure, then your boiling point is going to be lower. For example, water boils at 100 degrees Celsius at sea level, but if you go on top of Mount Everest, it's going to boil at like 95 degrees Celsius or something like that. So it lowers the boiling point if you have less pressure because there's less forces to escape. Condensation is when you go from a gas to a liquid. So I'll move this so you can see that. This is when the molecules lose energy. Remember, you're going from gases, which are moving around, to liquids that are just kind of flowing. So that's much less energy. When they lose that energy, they're going to start sticking together because they don't have the energy to escape from each other's forces. Freezing is going from a liquid to a solid. So molecules lose so much kinetic energy that they just stick together and they kind of just vibrate in place. Once in a while, a molecule might actually move position, but generally it just kind of stays right there. All right, there are two other funky ones, and sublimation is the first one, and this is probably the one you might be familiar with. Have a solid going directly to a gas. So this is like when you have dry ice. If you've ever seen dry ice, it looks like this big and then suddenly you've got all this gas coming out of it. Okay, there's no liquid ever with it. It's frozen carbon dioxide going straight into carbon dioxide gas. You might see this like in a haunted house if they want to make all that vapor on the floor or in a play or something to make it look very woo spooky. So that's a sublimation reaction when you skip over the liquid phase and go right to the gas phase. And the last one is deposition, and that is going straight from a gas to a solid. All right, best of luck on this section. I will see you in the next set of notes. Make sure you talk to me if you have any questions.